Module 2, Lesson 12, Estimating Digits in a Quotient. So we are moving on from adding and subtracting and multiplying decimals to dividing, and we're going to start with some place value concepts dealing with estimation. Lots of benefits to estimation. One of them is it really demonstrates a great amount of number sense. The other is it helps us decide if our answer is reasonable. So today I can explain the connection between estimation and the standard algorithm for division. So we are going to look at estimation concepts and see how they take us into the standard algorithm. So we're going to start with something easy so that we can understand it, and then we will try to apply it to things that are a little bit more difficult. So we're going to start with 150 divided by 30, and I'll tell you straight up, the quotient on this is a 5, so we can worry about the process, the thought process that we're going through, instead of worrying about the answer. So the first question is, how could we represent this problem using division notation? And we could write it as 150 divided by 30. Now, connecting back to what we did with fractions, how could we write this a different way? Perhaps turn this into a unit form. And I could write it as 15 tens divided by 3 tens. And if we remember back to the fraction form, the unit form, these tens will then divide each other out, and I will be left with 15 divided by 3. So I have this 150 divided by 30, and I've got that as 15 tens divided by 30 tens. And the tens divide each other, 15 tens and 30 tens. How about 3 tens? The tens will divide each other out, and I will have 15 divided by 3. And this is a very simple problem. And once again, we'll see that the quotient is 5. What we're looking at is finding some units in here that we can cancel out so that we can estimate an answer. If we were to write this in regular division form, it would it would look like this. Here's our 150 divided by 30. I've left the grid turned on with the idea that it helps us see what's really happening here. It helps us line up our place value positions so we see where things are at. So 5 times 30, we get 150. We subtract, and we have a difference of 0. So it helps us estimate. So taking a look here at a more complex problem, we are going to try and take this division problem here, and we're trying to go and get a one-digit divisor. That's what they mean with a one-digit arithmetic fact. We're going to try and get this down to a one-digit divisor so that we can also wind up with a one-digit estimated quotient. Starting simple here. So what number can we round the divisor to? This 38 here is pretty close to 40. So we'll say that we round that to 40. Then we need to take a look at the dividend. And what shall we round the dividend to? Well, we'd like to find something that is really easy to divide by 40. And in my head, there's two options that come up. And one of them is 24,000, and the other one is 28,000. It's kind of in between both of those. And for this example, we'll round that to be 24,000. So we'll wind up with an estimated quotient here, 24,000 divided by 40. And now what we'd like to do is turn this into a single digit divisor. Instead of 2 digits, instead of dividing by 40, we'd like to get this to be a single digit divisor. And this comes back to our unit form. I can think of the 40 as 4 tens, and I can think of the 24,000 as 2,400 tens. And when I have the tens, I then have 2,400 divided by 4. And at that point, I can start to see this problem as 24 divided by 4. And 24 divided by 4 is 6. So I know that an important part of my quotient here is going to be 6. This 24 divided by 4. And now I need to start and do a little bit of scaling up here. I've taken that really big division problem. I got it down to 24 by 4, scaled way down. And now I need to start scaling back up to the problem that I started with. I need to start adding back in all those place value positions that I have estimated down. So 2,400 divided by 4 would give me 600. So I multiplied my 24 by 100, and my quotient also got multiplied by 100. So I took the 24, multiplied it times 100, and got 2,400. And my quotient, 6 times 100, and so it became 600. This next step, we're going to do one other thing here. We're going to take the 2,400 and multiply it times 10. We're going to take the 4 and multiply it times 10. So the 2,400 will multiply by 10, and we'll get the 24,000. And the 4 will multiply times 10, and we will get the 40. Because I have multiplied the dividend and the divisor by the same number, the quotient will remain the same. It stays the 600. So I'm back up to my original problem right here. Well, my estimated original problem. And I have an estimated quotient of 600. Now I know that can be a little bit overwhelming, lots of steps in there. We're going to look at some examples and some exercises to try and clarify that, but I'm trying to give a nice in-depth look of what's happening here. So a good estimate for 26,897 divided by 38 is 600. And we can punch it into a calculator. And when we punch it into the calculator, we would find a quotient of about 707 and 8200ths. Now we have to ask ourselves, is our estimate pretty accurate? Well, looking at the size of the numbers that we're working with here, to have an estimate of 600 and then have a quotient of about 700, I would say that we are pretty accurate. We're in the same place value. We're still in the hundreds. Now, if we were dividing hundreds by tens, that's not a very good estimate. But because of the size of the numbers, we've got a pretty good estimate going on here. All right, so kind of walking through the process here a little more quickly. Here's these exercises. We're going to round to estimate the quotient, and then we're going to use a calculator so that we can find the quotient, and then we're going to look and say, how is our estimate? So the first thing we want to do is say, what can I round this divisor to? And 11 is pretty close to 10, so I'm going to have a divided by 10. And now I'm looking for a number that is pretty easy to divide by 10. Looking at the dividend here, and this is pretty close to 3,000. So I'm going to estimate this as 3,000 divided by 10. I'm going to think of this in terms of units. 300 tens divided by 1 10. So the tens will cancel out, and I'm left with 300 divided by 1, so I am estimating a quotient of 300. And then I can pull out my calculator here. 2,970 divided by 11. And the calculator says we should have a quotient of 270. Now the question is my answer compared to my estimate pretty reasonable? Well, looking at the size of the numbers that we're working with here, thousands divided by tens, to be within 30, I would say that I've got a pretty reasonable estimate. And of course, the calculator told me what the answer is. So 300 is a reasonable estimate, and I've got a quotient of 270. Now this 300 divided by 1. As I was scaling back up to check, I'm undoing what I did. I had divided by the tens, so I'm going to multiply by the tens. And that brings me back up to 3,000 divided by 10, my original estimate. All right, exercise 2. Round to estimate the quotient. So I've got 12s here. By the way, I want to point out a little pattern that we're working with. We started out with 11 as a divisor, and we have moved to 12 as a divisor. Just going to watch that for a minute. So 12 is pretty close to 10. So once again, I have 10 as a divisor. And looking at the dividend, I'm going to look at that and say that's pretty close to 5,000. I could also say that it's pretty close to 4,800. So I'll get a little bit better with my rounding here. Thinking about my units, this 10 is 110, and the 4,800 is 480 tens, so that my tens will cancel out, and I've got 480 divided by 1. So I've got an estimate, an estimated quotient of 480. So now I can punch into the calculator here, 4752 divided by 12, and that gives me 396. Now I want you to notice that on the last problem, we were within about 30. Our estimated quotient was about 30 from our calculated quotient. This time, 480 minus 96, and I'm going to put an estimate here. Well, I don't even have to estimate. We're 84 away. Notice that our estimated answer is a little bit further away from our actual quotient. Observing patterns here. All right, taking a look at exercise 3, and we are going to round to estimate the quotient. So right here, I've got 19 as a divisor, and I'm going to round that to be a 20. And I am looking at this number and asking what could I round to. And I think that I'm going to round that to be 12,000. Nice, easy number to work with the 20. And I'm going to write this as 2 tens. And then this is going to be 1,200 tens. So the tens will cancel out, and I've got 1,200 divided by 2, which will give me an estimate of 600. And now I've got 11,647 divided by 19. And that gives me a quotient of 613. So the difference between my estimate and my calculated quotient is 13. once again, kind of observing some patterns up here in this corner, seeing some patterns emerge that we'll talk about as we get a little further in the lesson here. All right, looking at exercise 4, we are going to round to estimate the quotient. 18, I will round to be 20. And boy, it would just make sense to take this 40,644 and make it 40,000. And write the 20 as 2 tens. And then I've got, I'm going to divide a 10 off here, I've got 4,000 tens. So the tens will cancel each other out. And I've got 4,000 divided by 2 for an estimate of 2,000. And I'll pull out my calculator. 40,644 divided by 18. And that's going to give me 2,258. So I had a divisor of 18. And I then got a difference between my estimate and my quotient of 258. Now, something that I'd like us to observe, and it's going to set us up for the next example that we look at. When we rounded, 19 was only one digit away from what we rounded it to. The 19 rounded to be 20. So we rounded up to 20, so it only moved by one number. With the 11, we rounded to 10, so it only moved one number. With the 12 and the 18, it moved two numbers. The 12 rounded down two numbers by a count of 2 to be 10, and 18 rounded by a count of 2 to be 20. And you'll notice that our estimates were further away. The farther we had to round, the farther our estimate was from the calculated answer. So we're going to pose a question here on this next slide. What patterns are you seeing between the estimates and the quotients? Is there a connection between the digit in the ones place in the divisor and the accuracy of the estimation? So we were looking at 11 and 12, and we looked at 18 and 19. Well, except we went the other way. Looked at the 19 first, and we looked at the 18. A connection between the digits in the one place in the divisor and the accuracy of the estimation. Well, the closer the digit in the ones place was to what we rounded to, the more accurate the estimate was. 11 is really close to the 10. The 12 is a little bit further away. It's 2 away, and the 11 is 1 away. This was a more accurate estimate than this. The 19 to 20 was 1 away. The 18 to the 20 was 2 away. Then this was a more accurate estimate. So a 4 in the ones place. Do you think our estimate is going to be as accurate as what we did in the first 4 exercises? Well, if I take the 14 and I round to 10, now we're moving 4. We've got a difference of 4 instead of a difference of 1 or 2. So in my head, I'm thinking these estimates will not be as close to the calculated quotient. So once again, working on some number sense here. So if we were to round the divisor to a multiple of 10, would you round to 10 or 20? Now we're looking at the problem that we just saw on the last slide here. And I should have written it down up in the corner. And we've got 59,262. And we are dividing by 14. So would I round 14 to be 10 or 20? Normally, we would usually round that to be a 10 because 4 tells us to round down. And then taking a look at the 59,000, we would probably round that to be 60,000. So how would we estimate the quotient? Well, I would take the 10 and write it as 110, and the 60,000 would become 6,000 tens, and I would have an estimated quotient of 6,000. And of course, it's now going to walk through how would we round the dividend. All right, so there's our 60,000 divided by 10, and our estimated quotient would be 6,000. There we go. Slides have caught up with where I was. And then we would actually divide 59,262 divided by 14. And we have 4,233. Our estimated answer was 6,000. Notice how we are a little bit further away from the calculated answer. Well, that shouldn't be a surprise because we are rounding 14 further to get to 10. Is our estimated quotient more or less accurate? Well, it's a little bit less accurate. The 14 had to change a lot more to become a 10. All right, taking a look here at exercise 5. We're going to round to estimate the quotient. So 5 here is even further away from the 10 or the 20. It's much, much further. So our estimated quotient is going to be further away. So 15 would probably round to be 20 if we follow all the rounding rules. And 49,000 will become 50,000. And 20 becomes 2 tens. And this becomes 5,000 tens. And 5,000 divided by 2 is 2,500. So I have an estimated quotient of 2,500. And now we'll actually do the division. And we are 3,278. So we are pretty far away from our estimate, but we expected that because 5 is a long ways from 10 and 20. So we're not too surprised. Now, if I were to round the 15 to 10, 50,000 divided by 10, I've got 5,000 divided by 5,000 tens. Divided by 110, and there I've got an estimated quotient of 5,000, which is also a very long ways away from 3,278. So we can see the further we get from the number, well, when we round, the further we get from the actual number of the divisor, the further away our estimate is going to be, which starts to tell us we need to be choosy, picky, about what we round these divisors to. We round them too much and our estimates become very inaccurate. All right, taking a look at another example here, connect estimation to the division algorithm. So the first thing we're going to do is estimate the quotient, 27. I'm going to round that to be a 30. And I've got 918, and I'm going to round that to be 900, which will leave me with 90 tens divided by 3 tens, which leaves me with 90 divided by 3, which leaves me with an estimated quotient of 30. And now we're supposed to use the division algorithm. So I've got 918 divided by 27. So we're going to go slowly through here and make a connection, hopefully, between our estimate and using the division algorithm. So I've already estimated a 30 here. If we were using the division algorithm, we'll take this 3 here and we'll multiply it by the 27. 27 multiplied by 3. 3 times 2 is 6, plus 2 is 8, and I'll find that I have 81. Now that 81, well, let me back up for a second. Where do I place the 3 in my quotient? Well, I estimated this as being in the tens place. It's 3 tens, so I'm going to put the 3 in the tens place in the quotient. And when I multiplied and got 81, this was multiplying by tens, so this 1 goes in the tens place, and the 8 will go in the hundreds place, and I will subtract. And at this point, I can bring down the 108, and I can continue to work. So I knew multiplying times 3 gave me 81, and I need to get to 108, so I'm going to try 4 now. 27 times 4. 4 times 2 is 8, plus 2 is 10, and I got 108. So 918 divided by 27 is a quotient of 34. My estimate was 30. I'm in the ballpark. I'm in the right spot. Now we're going to look a whole lot more at the standard algorithm, and we're going to practice that a lot more. I know that some students are overwhelmed by that. All right, so benefit of estimating before we divide. Estimation is a great way to look at our work and say, what do I think the answer is going to be? And then we actually do the work and see how we did. So our estimates help us determine whether or not our answer is reasonable. Another benefit is it gives us an idea of where to start as we are working the quotient. So what did we notice about divisors that are closer to multiples of 10? Well, the closer the divisor is to a multiple of 10, the more accurate my estimate was, the closer it was. The further away my divisor was from the multiple of 10, the less accurate my estimate was. And what is problematic with divisors with the digits 4, 5, and 6 in the ones place? What problems do we have? Well, the estimate is less accurate. As we get further away from the nearest 10, our estimates become less accurate. So in some upcoming lessons, we're going to see that even though these are less accurate estimates, we can use other mental math strategies to help us when dividing. And in class, I'd have you at this point just brainstorm what are some mental math strategies that you might be able to use to help you out with your estimates. So that concludes Module 2, Lesson 12. This is a very deep lesson as we talk about estimation and rounding and using our place value understanding to make some estimates and predictions about quotients, and then connecting that to the standard algorithm. But hopefully you're seeing a connection between estimation and the standard algorithm. Hopefully you can look and say, hey, I can make an estimate for what a quotient is, and then I can look at my answer and say, does my answer match or is close to my estimate? So that concludes Module 2, Lesson 12. If you've got questions, make sure you talk to your teacher. Make sure you complete your problem set